I'm James Johnston, Manager of Training and Support at Microsurvey Software. I'm pleased to talk to you today about the microsurvey product, StarNet. StarNet is a well-known least squares adjustment package. It's a little bit unique in the world in that it's one of very few packages that are devoted entirely to performing least squares adjustment. An advantage of working with a dedicated least squares adjustment package like StarNet is that it makes it easy for you to work with information from a wide range of brands of surveying sensors. It also makes it very easy for you to combine data from different types of sensors, i.e. GNSS, leveling, and total stations. It makes the workflow relatively simple when you're trying to combine conventional and GNSS data, and it has a real advantage in making it simple to use the most rigorous methods for computations. A very practical advantage of using StarNet in particular is it makes it simple to identify and eliminate field errors, and you're always going to be reporting results with higher precision. So the simple fact that you're using least squares adjustment, if it's done properly, will make your surveying more precise, and it gives you a lot more confidence in all your projects because you have a good idea of what their precision is, and because you know that you've effectively eliminated errors. On this next slide, I'm going to give you kind of an overview of what a typical workflow is with a StarNet project. So here we're looking at the StarNet interface. And the first step in general when you're working with StarNet is you're going to use the many input options for importing either GNSS data, or you may be running a converter, which is a separate program in order to compute StarNet input data. It's going to be added to the project, and then you can start on to the second stage, which is all of your data will be listed as a text file in the editing center here, and sometimes you need to make a few small changes to the input data before StarNet can make sense of it, and you can make modifications as you work. The next stage you'll see up top, you'll see the little lightning button, is to simply hit the adjustment button. Once you've got things imported, you will do no harm in adjusting and coming to your first solution. Something that makes StarNet a little bit special to work with is it doesn't require you to go through a series of distinct stages in order to achieve an adjustment. It's just one button press. The software will check to ensure that you've got enough information for a minimally constrained adjustment. It will compute approximate coordinates internally, and then it performs a least squares adjustment. The output may be correct or it may not be, but once you've got output, it makes it very easy for you to start troubleshooting your work and starting to come to a solution. This is the next stage. After I've run my adjustment, you'll notice how we've got the processing summary over on the left-hand panel. And the first thing that you're always going to inspect when you first run an adjustment is whether or not the chi-square test has passed. And all it's doing is it's comparing the total error factor against the range that's identified in the lower upper bounds. You're also going to inspect the error factors that are listed for both directions and for distances. So you'll see in this listing here that each of the error factors is close to 1, and that's exactly what you're looking at in a properly weighted adjustment. In the ideal world, all those numbers would be 1. You're also going to take advantage of the network plot so that you can learn more information about your adjustment. You'll notice how it's got color coding and symbol coding, and it's got different line types that help you to identify different types of input data. And you can tell from the graphical plot how things are fitting together. Another very important part of StarNet as you're performing your adjustment is you'll want to have a look at the listing, which is a much more detailed expression of the information we saw earlier in the processing summary. What it will do is give you all the statistics that you need to know about your adjustment. It will tell you how well each and every measurement in your input has fit into the overall system. And very importantly, it has features that allow you to find outliers and make corrections. And if you do make a correction, then you just run the adjustment again. Rinse and repeat until satisfied is a simple way to explain the process when you're running StarNet. When you get to the point where you're satisfied with the contents of the listing and you're satisfied that your input data is all correct, then the final result is StarNet will create an ASCII file for you, so you can output either latitudes, longitudes, coordinates, or what's called a ground file, which is a transformed output of your adjustment. You can also output a KML file and have a look at the results in Google Earth. You can output a DXF file in case you want to insert a drawing that shows all of your air ellipses into a CAD program. And we've also got detailed reports. The listing and the network plot can be printed in the reporting section of the tool, and you've got your final results. And that, again, I'll say is the real advantage of working with StarNet, because what you'll see is you have results that are very detailed. You've got listings of all your coordinates, and you know what the standard deviations are, and you've got the information you need to ensure that the data you're reporting does not have errors in it. And that in the long run always saves money, because it means less mistakes, less revisiting the job site, and faster results. So thanks for learning about StarNet at a very high level, and be sure to ask questions if you need to. Thank you.